So hey guys, welcome to my channel Code with Kai, and code for today is lead code number 744. Find smallest letter greater than target. So this is video number 3 of binary search playlist. So let's get started. So suppose we have letters A C E G K M X Y, and we want to find element that is more than target. That is, let's say the target is L. So what is greater letter than L in the current list that you can see right here? Okay, if you observe the letter immediately greater than L is M. So that is what we want as an answer. Okay, so let's just perform linear search. Let's just understand what we can do using brute force. So the first solution that came to my mind is, let's just go from start from 0th index and do a search one by one. Okay, so let's say if the number is uh, at I is equal to 0, we have A. Is A greater than L? The answer is no. So I'll just move on to the next element and check. Is C greater than L? The answer is no. Then I'll move to the next index. Is E greater than L? The answer is no. We'll move on to the next index. Is G greater than L? The answer is no. We'll move on to the next index. Is K greater than L? The answer is no. Okay, then we'll get M. Is M greater than L? The answer is yes. So that is what we are going to return. Once we get the answer, we are going to return that. Okay, so with using linear search, the time complexity we will face is O of n. And since we are not using any extra space, the space complexity would be O of 1. So let's just code the solution and we'll get back to the optimal solution. It is quite simple. What we are going to do is we are going to do a simple loop. Int I is equal to 0, I less than letters dot size. We are going to do I plus plus. As soon as I find an element which is more than target, letters of I is greater than target. Okay, I'm going to return that element, return that character. Okay, otherwise we have not found any greater element. In that case, we are going to simply return the 0th element. Okay, so let's run this code and let's just submit it. Yeah, so it passes all test cases and it works. So let's now move back to discuss the second solution, that is how can we solve this using binary search. So let's discuss an optimal solution now. So let's say this was our list of letters, and let's say we do S as right here and we set E right here, the starting and ending index of the binary search. Once we set the starting and ending index of the binary search, we need to calculate mid. Remember, we need to calculate mid. So the first step was set S and E. Second is to calculate mid. So let's say the first iteration was uh, 0 plus 7 by 2, that is S plus E by 2. The answer we got for mid was 3. So this is where the mid is pointing. Now we are going to compare. We are going to do a simple comparison. Okay, so we are going to do a simple comparison. If my array of mid is greater than target, what does this mean? Okay, so what does this condition mean? We will first understand that using an intuitive way. Okay, so let's think of a number line. Okay, where the starting and ending indexes are set. Then we have this condition, array of mid is greater than target. So this is array of mid. It is greater than target, so the target must lie on the left side of this mid. Okay, when we say it is greater than target, we can be sure that the element never lies on the right side of this particular array. Okay, That means we can take this end pointer and move it right here. Okay, since the target never existed on the mid or to the right of the mid. Okay, what is the another condition? If this is false, let's say this was my mid array of this was my array of mid, and if this condition was false, we will do something else. What we will do? Okay, array of mid is greater than target. Array of mid was greater than target. Now it is array of mid is smaller than target. Okay, otherwise the array of mid is smaller than target. That means this could have been a potential target. Okay, so target must lie on the right side. So in that case, we'll take the s pointer and point it to mid plus 1. Okay, so this is where the s pointer would be. Now we know why this condition is important. Again, I have explained the same thing in previous videos as well. Okay, so let's just get back to the example where we want to find the element that is greater than L. So what we'll do is we'll do the mid calculation first. So let me take this and move left side. Okay, and I'll draw a line. I'll do the mid calculation by setting s is equal to 0 and is equal to 7. Okay, and the mid is equal to s plus e by 2, that is 7 by 2. 0 plus 7 by 2, that is going to be 3. Since I've already set the mid right here. Okay, so mid is pointing at G, and we will check if array of mid, that is G, greater than target. What is my target? Is G greater than L? The answer is no. Okay, so else block will be executed. Okay, so what is in the else block? Since it is since array of mid is greater, so the mid element is greater, then the target must lie on the left side, but that condition has false, so the target is lying on the right side. So in that case, we are going to do s is equal to mid plus 1. Otherwise, we'll do e is equal to mid minus 1. Okay, so let me explain again why we did this. So array of mid, if you draw a number line, array of mid was right here, and it is greater than target. Okay, so it is greater than target, but since we are executing the else block, it is not greater than target. Okay, so array of mid must be smaller and target must be larger. So this was the target and this was array of mid. Okay, I'll just call am. So it exists on the target lies on the right side. That means the target never lies on the mid or on the left side of the mid. So s, wherever the s was set, we have moved to mid plus 1. So if this was array of mid, we are going to set the s as right here. Okay, if this much is clear, let's just get back to the code. Okay, so this condition will be executed, this else part will be executed, and s is equal to mid plus 1. What is mid? Mid is 3. So s is going to be mid plus 1, that is s is going to be pointing at 4. Okay, now we'll do the mid calculation again. Okay, let's set the s as 4, e as 7. Mid is equal to 4 plus 7 by 2, that is going to be 11 by 2, that is going to be 5. Okay, so the mid is pointing at 5. This is where the new mid is pointing. Now we will check this condition again. We'll check this condition again if array of mid is greater than target. Okay, so what is array of mid now? Array of mid is m. So we'll check if m is greater than target. Is m greater than L? Yes, it is true. M is greater than L. That means a target never lies on the right side now. Okay, so what we can simply do is we can take the e pointer and move it right here. So that is what I'm going to do next, and I'm going to exclude this target. Okay, and for this as well, I'm going to remove this out since this was removed from the previous case. Okay, and now in this current case, this is removed. Okay, our e pointer and s pointer is pointing at 4. So let's do dry run again. So my s pointer is pointing S is equal to 4, E is equal to 4. The mid will also be 4. That is S plus E by 2. Since the mid is 4, now we will check if array of mid. What is array of mid? Array of mid is so this is where the mid is pointing. This is where E and S are pointing. We will check if array of mid, that is K greater than L. The answer is no. The K is not greater than L. Okay. So this else block will be executed. That means S is equal to mid plus 1. What is S? S is 4. Okay. So S is going to become 5. Okay. So after that, S was 4. S will become 5. And where is E is pointing, going to be pointing at 4. And where is mid? Mid will be pointing at 4. So E and mid are pointing at 4. But we wanted the next greater element. Okay, the next greater element than target. So target was L. So we have to return the next greater. What is greater than L? We know for sure that M is greater than L. So where is S pointing? S is pointing at the fifth index now. Remember, S is pointing at fifth index. S is not pointing at fourth index. That means we are going to return S in this point. Okay, so the S is going to store our answer, will return S. But let's take another example. So let's say we have elements like this: A, G, H, K, M. Okay, and we want to find an element that is greater than M. Okay, so the letter that we want to find, the target that we want to find, is greater than M. Okay, so do you see any element that is greater than M? I do not say it. Okay, in that case, the question clearly states that you should return the 0th index. Okay, so let's see our program logic is able to handle it. So let's just do dry run quickly. S pointer is set here, E pointer is set here. It is 0, 1, 2, 3, and 4. So let's just do S plus E. Okay, let's start from the beginning. We'll check if array of mid is greater than target. In that case, I'll have to do end is equal to mid minus 1, or else I have to do S is equal to mid plus 1. Okay, so I have written this code. Now let's do the mid calculation. So let's start. S is equal to 0, E is equal to 4. So my mid is going to be 0 plus 4 by 2. That is going to be 2. So this is where the mid is pointing at. Now I will check if whatever is at mid, is it greater than target. So my mid is going to be H. My target is going to be M. Is H greater than M? The answer is going to be no. H is not greater than M. In that case, the left side is entirely excluded. Okay, so that means S pointer has to move to mid plus 1. So this is where the S pointer is going to move next, and this entire thing is going to get discarded. Okay, so my S is pointing at K, my E is pointing at M. Okay, so let's quickly erase it out, and let's do the mid calculation again. This is going to be the next iteration. So S is going to be 3, E is going to be 4, mid is going to be 3 plus 4 by 2. So the answer is 3. We'll check if array of mid, that is array of mid, so this is where the mid is pointing. If array of mid is greater than target, so that means is K greater than M? The answer is no, K is not greater than M. In that case, what we will do is we will again execute the else part, that is S is equal to mid plus 1. Since the target never lies on mid, it should be mid plus, S should move to mid plus 1. Where is mid? Mid is pointing at 3. Now it will go to mid plus 1, that is 4. So this is where the S will point. S will be removed from here. Okay, and once this happens, we have S and E pointing at 4. So let's quickly erase it out. Let's say S is 4, E is 4, so the mid will also be 4. Okay, so let's just remove mid and point it right here. Okay, so we will check this condition again. If array of mid is greater than target, if array of mid, what is array of mid? Array of mid is m. Is m greater than m? The answer is no, m is not greater than m. Okay, so this else part will be executed again. S will be pointing to the next element, but there is no next element. Okay, so if s was 4, it will become mid plus 1. What was mid? Mid was 4, right? So s is going to become mid plus 1. Mid was 4. S is going to become 5 now. So when the condition ends, we have s as 5, e as 4, and mid as 4. So you see, s is actually pointing at element which does not exist. That means this is where the s is going to point, right? So this is where the s is pointing at. This is where the s is pointing at. This is where the e is pointing at, and this is where the mid is pointing at. So it is pointing at an element which does not exist. Okay, so this is going to be problematic. To solve this, what we can do is, when this happens, we are going to return the 0th index. Okay, that is what the question asked us to do, remember? So if we cannot find an element that is greater than m, we have to return the first letter of this particular thing. Okay, so in code wise, we can handle this using if s equal length of the array, that means we have to return the first letter of 0. Otherwise we have to return letters of s. So that will contain our answer. Okay, so we have done dry run on 2 examples. Now let's just get back to the code and finish up the code. Okay, so let's solve in Leetcode. We have class solution, and let's perform a binary search solution. Int s is equal to 0, and let's just calculate the size of letters dot size. Then we do int e is equal to n minus 1, and we'll do binary search while s is less than equal to e. We're going to calculate mid is equal to s plus e minus s by 2. This is the safe way to find mid. And if array of mid is greater than target, okay, I am going to say e is equal to mid minus 1. Otherwise, s is going to be mid plus 1. And if this is true, then I'm going to return letters of s. But if I run the solution now, I'm surely able to miss it, right? So okay, there is no array, there is letters. Okay, remember there was a caveat in the solution. So run it less than equal to mid. Okay, so yeah, I expected a buffer overflow since we are trying to access an index which does not exist. Okay, to fix that, what we can do is we can check a condition before, that is s equal n, and if that is so, then letters of 0 we have to return. Otherwise we can return our answer. Okay, so let's quickly run this, and it works. So let's submit it. And the submissions, okay, so we have passed all the test cases and it runs. Okay, so that's it for the video. Have a great day. Bye.